Hello, everyone. We're working through an introduction to statistical methods and data analysis by Ott and Longnecker. We are on chapter 12, part 2. All right, if we wanted to test to see if there's a relationship between xj and y, we're going to carry out a hypothesis test for the slope. All right, so we can say HO, beta j equals 0. So the true slope, is it equal to 0? Okay. Right, if the true slope's equal to 0, as xj increases, nothing happens to y, the slope is 0, right? The alternative would mean xj is not equal to 0, either you have a positive slope or a negative slope, right? But as xj is changing, y is also changing. Okay, so what are we going to do? We're going to calculate the test statistic. We're going to take beta hat j, divide it by the standard error beta hat j. Now note that this is really beta hat j minus our hypothesized value of beta j, which is 0, and divide by the standard error of beta hat j. Now, we know that if HO is true, we can calculate the distribution of our test statistic, right? If HO is true, beta j equals 0, so the expected value of beta hat j right here, that's equal to 0. And our standard error of beta hat j is given by the equation that we've seen earlier in this chapter. That's our S epsilon divided by the square root of the xij minus x bar j squared times our 1 minus r squared j's. Our degrees of freedom is still in minus k plus 1. All right, draw a picture of the distribution. Okay, if we have a t distribution, we know that it's symmetric around the hypothesized value of beta j, which is 0. All right, we get a value of beta hat j. That's somewhere on this curve. It's either bigger than 0 or smaller than 0. Okay, we can calculate, we can find beta hat j. And essentially when we get beta hat j, we can then get the t value, our test statistic that's associated with that, by doing beta hat j divided by standard error of beta hat j. Okay, and then this area above the observed value, that's called our p-value right there. Okay, if we're doing a two-sided test, then whatever our test statistic is, then we have to think about being that far away on the negative side, and both of those taken together would be your p-value for a two-sided test. So it really depends if you're doing a one-sided test or two-sided test, what your p-value is equal to. All right, if you want to, you can use your calculator to calculate the p-value, or you can use R. Either one will work, and we'll walk through how to do that as well in R. But before we talk about how to calculate, we're going to make a decision at the alpha level of significance, right? So if our p-value is less than alpha, we're going to reject H0. So if we set up our curve, right, and if we had a two-sided test, right, we're going to put alpha over 2 in each of the tails, right? From there, we could get our critical value, right? And this one over here is going to be negative. All right. Essentially, though, if our p-value is less than alpha, that means that we're further in the tails, right? That means that we're somewhere further in the tails. Okay. So by doing that, if we take those together, our p-value is going to be less than alpha. Okay, I apologize. I didn't mean to use a rainbow pen. Maybe something like orange would look better, but for now, we'll just leave it as a rainbow pen. Okay, if our p-value, using a different color, if we are not quite yet at the rejection region, right? This is reject HO. Or somewhere over here, then we would take these two sides and all of that would be our p-value. And in reality, in the orange case, we were in the fail to reject region. So if your p-value is greater than alpha, we're going to fail to reject HO. Okay. Interpret your decision in context of the problem. If you reject HO, you're going to say XJ predicts Y, given that all other X's are already in the model. And if you fail to reject HO, you're going to say XJ does not predict Y, given all the other variables are in the model. Okay, now let's talk about the p-value.